Okay, now that we have formulated the finite difference equation by approximating derivatives, we're going to use an alternative formulation which uses Darcy's law on conservation of mass. So in this case, we are going to look at the same node I, but in this case we're going to look at this space right around that node, and the width of that is delta x and the height is delta y. And we're going to, the flow in the x direction, it comes in on the left and goes out on the right. The flow in the vertical direction comes in through the bottom and out through the top. So what we're going to do now is we're going to use Darcy's law, and then again conservation of mass, and see what happens. So the flow in is from the left and the bottom. The flow out is from the top and the right. So the flow in, basically we apply Darcy's law to both of these cases. Now let's go back just a little bit here. So the flow in is going to be kx. Well, we are using kx in this case. So kx times hi minus hl over delta x. So this is we're looking at flow across this boundary here. So the hydraulic gradient is hi minus hl. The distance is delta x. And the cross-sectional area is delta y. So that's this term right here, minus kx, hi minus hl over delta x times the area, which is delta y times 1. That's a unit thickness in the perpendicular direction. And then coming in from the bottom, we have hi minus hb as our hydraulic gradient. The cross-sectional area is delta x. So that gives us this term here. And likewise, for the flow out, we look at hr minus hi. So that's, that is hr minus hi divided by delta x. Cross-sectional area is delta y. And then here it would be, to go in this direction, it would be ha minus hi divided by delta y as the gradient. And the cross-sectional area is delta x. So that's this term right here. So now we have, using Darcy's law, we've come up with an equation for q in and q out. And from conservation of mass, we set q in minus q out equals 0, or q in equals q out. So we just use those two expressions that we derived and set them equal to one another. If we multiply both sides by delta x, delta y, we get rid of the terms in the denominator. And if we solve this for hi, and then if we assume that kx is equal to ky, we end up with this expression, which is exactly the same expression we found above. And if we assume delta x is equal to delta y, we get hi is equal to 1/4 hl plus hb plus hr plus ha. So we've effectively come up with precisely the same result using Darcy's law on conservation of mass.